right. We don't know whether or not there's some sort of super compaction that allows the comet to be more firmly condensed and compressed than normal physical processes that we understand, or whether or not we're really interpreting the water loss right. And to be honest with you, I think we're misinterpreting the water loss. The facts state the water loss, the 80%, the 800 tons per second. I honestly, and just years of experience, I don't see how that could possibly happen. So that's a good question, very good question. Yes, sir.
Yes, sir. Can you say that whether or not they pick up material in the parts of the orbit that are far out into the solar system, or even do they orbit back to the Oort cloud?
They do not go back to the Oort cloud. Now, see, that's what I was touching on earlier. That would have been a hyperbolic comet. Once the comet passes the sun, we understand the physics a little bit better about how the solar system works now. And the physics really hasn't changed. It's just our ability to understand it just since 1971. All orbits of things like this, comets are kind of unique in the fact that they do come in pretty much in a straight orbit. You know, when they start, so you think, well, it comes in a straight orbit, swings around the sun, and exits in a straight orbit. That would be a hyperbole, or similar to one. Doesn't happen. What happens is that the speed increases so dramatically that it closes that orbit just from the basic physics of the orbit and the motion and the force of rotation, or revolution rather, as it's coming around. And nothing can escape without being locked into an orbit once it's placed into the sun. As long as it maintains that orbital velocity, it will always come back, and it can be, if it's undisturbed, it will always come back in a set period, like Halley's. Halley's comes in at a real sharp angle, and that's fortunate because none of the other planets have really perturbed it. Gravitation, like Jupiter, is so big. If it got close to Jupiter, it could change its orbit and it might shorten it, like Encke's, and it may be a 15-year comet, but it never has. It's always coming in at a very, very sharp angle, so nothing is around to actually change its orbit, so it's a very clock-setting 76 years. So they don't go back to the Oort cloud. We think that that's probably impossible. It would have to be an incredibly high-speed comet. And this is one of the fastest ones we've ever thought could even exist. And the speed alone is one of the reasons that the disintegration theorists have said this comet is going to disintegrate as soon as it gets to the sun. And granted, that's a lot of velocity, almost 1,000,000 miles per hour. We've never seen a comet other than what we call sun grazers, and those do disintegrate. This was not going through the sun's outer atmosphere like sun grazers. So it could disintegrate, it could fall apart. I don't think it's going to.
Another question, sir. What do you think was the cause of this comet suddenly de novo appearing? What happened to the Oort cloud?
I got a great explanation for that.
Oh, good.
Yeah, well, I meant to hit on it a little bit when I was telling you about how we have the two different types of comets. The Oort cloud is a very, very stable entity out there. It's just like the planets. They're fairly locked. As long as they keep an angular momentum, a speed around the sun, and the shape of the orbit doesn't change, a planet's pretty much going to stay where it is. If we launch a rocket from the Earth and we shoot it up, the trajectory and the amount of energy needed to achieve escape velocity and the angle it has to reach to escape out of the Earth's gravitational field eventually will bring that object back into the Earth. Okay, there's a big difference between a locked orbit of a planet and an artificial trajectory. A good example is the moons of Mars. Mars has two moons. They're very small, Deimos and Phobos. And I'm getting to your, it's a very good question, I'm getting to it. Deimos, believe it or not, I'm getting to it. Deimos and Phobos are actually spiraling back down to Mars. We determined that about 20 years ago. And the reason we are very, very sure about, I mean, not only are we seeing a degradation of the orbit, but the fundamental, we could trace it back to when they actually left the planet. Anything that is launched, if you don't go up and boost the orbit, you've heard about them having to boost the space station in a higher orbit to maintain its orbital velocity in order to maintain orbit. The same thing with Deimos and Phobos. These things were shot out of Olympus Mons, we think. I forget the exact, 3 million years ago roughly. And they were literally shot out of a volcano. They're two big rocks that came out of the middle of Mars. And they're orbiting now as satellites, and they can actually trace this back to the origin to Olympus Mons, a big volcano on Mars. So their orbits, they're just like launching a rocket on Earth. Without something to boost them into a higher orbital plane, they're going to come back down. Now, on the comets, and your original question, I'm sorry, ask me again.
What actually started this unique comet coming in from the Oort?
Coming in. Okay, I thought that's what it was. I want to make sure I was going to answer it. But anyway, you needed to hear this. The reason that the comets leave the Oort cloud, it is a very stable thing. There is no reason they should. Okay. Basically, you've got, let's just picture it as a big donut, just a chocolate-covered donut out there, and everything is moving as one unit, essentially. And there are minor, disturbances just through, basic solar wind, what little solar wind reaches it. At 12 trillion miles, there's not much influence from the sun. But there are objects in the interstellar medium that do pass. We don't see them because they're far away and most of them are dark. There are objects that stir things up. And these objects have been Ubera, Nemesis, some of these objects that people say are out there that we just haven't been able to discover. There are objects out there, there's no doubt about it. And they do swing in irregular orbits from time to time. It may not even be the same object, but something does stir comets. And one of the studies that I was involved in years ago is looking at the frequency of large numbers of comets. Like one year we may get 200, the next year we get 5, and then 20 years later we'll get 200 more all at once. Why is that? And so there's something out there periodically that does disturb the Oort cloud, and all it takes is something like that to simply begin to shift them our way. Once they move just the slightest amount closer to the sun, that's enough for the sun's gravity to continue that motion, that little bit of an offset, and turn it into angular momentum to where they actually are pulled into the gravity.
Does that imply that you have another planet beyond Pluto that's doing this, or do you think these are objects that just go into interstellar space and just have to brush by?
I think maybe both. I think there's no doubt that there is an object out there. There's a lot of gravitational studies that do suggest there is something out there that's dark. It's not a dangerous thing as far as coming into the Earth, but it is out there, and it can account for a lot of this disruption of the Oort cloud. It's not that far out. It's somewhere past the orbit of Pluto, certainly, but somewhere probably about half, I would guess not 1 trillion miles out, and it's something that's actually disturbing not just the Oort comet cloud, but even Pluto and Neptune as well. We're seeing slight perturbations on those planets that can be explained by something out there moving. But to that point, I do think there are interstellar objects as well. There has to be. The idea that there aren't little interlopers from time to time. The space is a busy place. It's mostly empty space, but there's a lot of stuff out there. And whatever this would be a very dark object that we can't see to reflect the light of sunlight. So certainly I think both applications.
One last one. Why do you think this is part of a comet as opposed to a meteorite?
Oh,
Or the same thing?
okay. I was going to explain that when we, and I want everyone to come up here. You can actually touch this thing. You can pull it out and play with it. Meteorites are very common, and this actually is a fairly common. The field that this came from, there are tens of thousands of them. The Campo de Cielo meteor field, which means field of the sky, is in Argentina. And in studying this thing, scientists are now believing it's very similar to the Siberian event. Whatever caused the fall exploded about 30 miles above the surface of the Earth, 30 to 33 miles, which is actually up in our stratosphere, right at the top levels of our atmosphere, out the stratosphere. And this thing rained down over a 200 square mile area, particles. And the number is so immense, and their configuration is so, how do I put this? They do not fit together as a piece. All of them are rounded, and all of them have a physical characteristics which suggest that they didn't break apart from the mothership. You see what I'm saying? So it's like one of these icy models that had the hard, stony parts embedded in it. There's been a lot of studies done on this site, and we're beginning to think that this was a comet. It would be the only comet field that we know of in the world that actually has particles. There's one in the Carolinas called the Carolina Bays. It actually is a very significant area, and it definitely was a comet. We have huge craters, and you can't see them anymore. There are lakes and swamps and marshes, and both of the Carolinas and part of Virginia are just covered over thousands of square miles from the Carolina Bays incident, which was probably, if I'm remembering right, was about 33,000 years ago. This fall was only 5,800 years ago. And we were talking with some individuals the other day about the fact that there were some archaeological sites that actually show fractures and damage that were being constructed at a period around 6,000 BC when this fall took place. So, but the entire geology of the area suggested it was an explosion above air, which sounds like a comet rather than a meteor. So that's why we're just saying. And I'm not saying this definitely is a comet. I'm saying it's as close to one as you're going to get. Okay? So touch it while you can. Yes, sir.
Are we the people in the eastern shore see the same thing as people on the west coast?
Yes. Only the East Coast people will see it sooner, and the West Coast people, just like anything.
The same.
Yeah, but parallax is going to be almost the identical. These things are so far away that the parallax is not going to matter from East Coast to West Coast. That's a very good question. No matter where you are on the planet, your time zone is the only displacement there. That's a good thing.
Sometimes they say the meteors.
Right.
Better
Right.
on the west coast than you can.
Yeah, you have to understand now, a comet is not an instantaneous event. It takes place over a very, very long period of time. So as this thing is progressively, moving through the sky, very little is happening. So what they see in New York City and then what you see here, what they see out in LA, it's pretty much going to be the same thing. Nothing will have changed dramatically. And if something explodes on a comet, it's not going to be like I can look in my telescope and be watching and see this big explosion all of a sudden. It's really odd. You lose a real concept of the distance because these events take place very, very slowly. And I showed you that 24-hour time lapse that the Hubble took of that one comet that exploded. That didn't just happen instantly. It happened over a full 24 hours. So pretty much what you hear from the East Coast is going to be able to be seen here too. Let's hope it all pans out. Okay, well, I certainly welcome you to come up here and touch and feel and